start going through number one. All right. You don't have to turn these in. I just want to make sure you're comfortable with them. Okay. So if you want to take notes on them, you can, but you do not have to upload these problems. Okay. These are not your assignment from today. That's totally different 7 problems. Okay. So let's look at number one. Okay. First of all, we got to determine, is this guy a function or not? So remember we talked about it's an input, output, okay? So in order for it to be a function, the inputs can only have one partner. Okay, so if you look at number 14, he only has one partner of 0. Okay, so right now, number 14, he is a function so far. Negative 25, he only has one partner. So he's a function. 24, one partner. 33, one partner. Okay? So all these guys have only one partner. I think in the video they talk about like a supermarket. This guy only has one price. Okay? This guy only has one price. It'd be weird if you went to the store and you were buying a Coke, and it's the same Coke but 2 different prices. Okay, and that's kind of how the video talks about this. The domain, this guy over here, which is the input, and we also call him the domain. He should have only one partner, only one price. Okay, if you watch the video, you know what I'm talking about. So this is a function, yes. Sometimes there's confusion because if you notice, 14 and 33 have the same partner or the same price. And think of it as a store. If you went to the store, there's items at the store that are totally different items, but they are the same price. Okay, and that's okay. The problem we get into is when you have one item with 2 different prices. That would make no sense at the store. So this is a function, okay? The domain. The domain is basically just your input here. All right, we're just going to list these numbers. So domain, if you recall when we talked about this, we put it in the squiggly bracket and we just list these guys. 14, negative 25, 24, 33. Okay, that's your domain. Your range is your output. So your output, your output is your range. Okay, so my range in this particular example is -1, 0, negative. I'm putting -1 once. You don't have to put it twice, and 5. Okay, so even though -1 shows up twice, we only have to write it once. Okay, the other thing I want to mention is, just to put more clarification, your input and domain is your X. Your output and range is your Y. Okay, we also talked about these are independent variables. Hopefully this is ringing a bell from a couple weeks ago. Independent and dependent variables is the range. Okay, so this is something we talked about actually this year, but this unit goes into a little more detail on functions. Okay, so that's how you do the functions. Let's go over number 2. I'm not actually going to do it, but I want to point out something. Number 2 is not a function. Okay, again, think about it as these are items at the supermarket, and this is their price. Okay, so let's pretend you're going to the store and you want to buy item 0. I don't know what that is. Okay, item 0, and you want to know the price. What if it gave you 2 different prices? So in this case, it's -1 and 1. It's which one is it? So since that happens, this is not a function. That doesn't work. You can't buy one thing and have 2 different prices for it, okay, at the same exact store. So this is not a function. Okay? So we're not even going to list the domain and range there. All right, let's jump over to number 4, because this one looks just slightly different. So number 4, instead of having it in a mapping type scenario, we have it in input-output point form. Okay? So your first number is your input. Second number is your output, or in another case, this is your X and your Y. Okay? So what we're going to look for is, we're going to look at the X. Think about this as the item at the supermarket, and this is his price. So if you buy item number 2 at the supermarket, how much does it cost? $2. Does item number 2 have a different price? So if you look, we're looking for X to have a number 2. So this X doesn't have a number 2. This one doesn't have a number 2. But here is item number 2 again. Does it have a different price than what we saw before? And the answer is no. It's the same price. Item number 2 is still $2. Okay? So we go here. Item number 4 is $2. Do I have a different price for item number 4? And the answer is no. Okay? Item number 5 is $2. Do I have a different price for item number 5? Nope. We already checked this guy. He's good. And then item number 6. Does he have, his price is $2. Is there a different price for item number 6? And the answer is no. So this is a function because all the items have their own price. Okay? What's the domain? Again, we're just going to list the X values. So we have 2, 4, 5, and 6. We're not putting 2 twice. Okay, so we don't have to put this 2 here because we already put it here. And then the range. Is all the Y numbers. So we have 2, 2, 2, 2, 2. So my range is all 2s, all my outputs. So we just have to write that once. Okay. All right. So number 5 is trying to give you a different type of scenario, not using numbers, but using, I guess you could say, a real life situation. So they want to know is the assignment of license plates to cars in a state. Okay. So think of it this way. The input for number 5 is all license plates. So all license plates that exist in the world. Okay? So this is my input or domain. And what it's saying is it a function if we do the state license plate? Okay, so think of this. All license plates in the world, or in the United States, well, they only have one partner for a state license plate. Okay, so think about that. You kind of have to think of it logically. So if you have let's think of this as the California license plates. So if I have a license plate over here from New York, well, New York have a partner in California. Okay? Or if I have a California license plate, will it also have a matching partner over here? Okay? I know it's kind of a bad example, but the answer to this is yes, this is a function. Okay? Because the way license plates work, one license plate belongs to a certain state. You can't have a New York license plate and a California license plate both be exactly the same in Texas. Okay? They are their own license plates. So, it is a function because one license plate per car. if you think of it that way. So our domain, as you can see, is all license plates. Okay, and our range is state license plates. All right, so that's kind of how you do that one. Not too big of a fan of that problem, but I thought I should go over it. All right, so number 6, we're looking at a function. Okay, so how can I figure out if this is a function? So we have to think of this logically. Remember, x is our input. So can you think of a number you can plug in here for x? Okay. For example, let's plug in x equal to 1. So if I plug in 1 here, we get 2 . Okay. So now we have order of operations. 1 squared is 1. 1 times 2 is, for this guy, is 2. 1 squared here is 1. 1 times 2 is 2. And 2 minus 2 is 0. Okay? So I plugged in, the input was 1, and my output was 0. Can 1 have a different output? Is there any way that when I just plug in 1, it only gives me one answer? Or can you think of a way where I plug in 1 and it still gives me a totally different answer? It gives me a second answer. Okay? So again, if I'm buying the item number 1 at the store, according to this function, item number 1's price is 0. Will item number 1 ever be a different price? With this function, the answer is no. Can you think of a number that you can plug in that will give you a different price or give you multiple prices? Okay? And to just cut to the chase, the answer is no. This is a function because every number you plug in only has one answer. Okay? So what's the domain here? Okay, so the domain is the numbers I plug in. Can I plug in any number for x? Is there anything telling me, hey, you can't plug in negative numbers here. You can't plug in the number 0. You can't plug in fractions. There is nothing telling me I cannot plug in numbers here. Okay? So that means my domain is all, we call it all real numbers. So any number we can think of, we can plug in for x. It can be my input. Okay? I know you have that watermark here. Hopefully you can see that. All right? Another symbol for all real numbers is this crazy looking R. So if you just put this crazy looking R there, okay, that's all real numbers there. Sorry, I mean it look like a P, but it's an R. Okay, it's an R with 2 lines going through it. Okay, my range, if I plug in any number here, so let's see. Right now my range is 0. I plugged in 0. What happens if I plug in 3? Okay, so let's see what happens. And you're going to notice something kind of funky happens. So if I plug in 3, so 2 to the times 3 to the second minus 2 times 3 to the second. 3 to the second is 9. 9 times 2 is 18. 3 to the second is 9. 9 times 2 is 18. 18 minus 18 is 0. And what you notice is I get 0 again. So what happens is no matter what number I plug in, I'm actually just going to subtract it away. That's what this means. I can plug in 100, but I'm just going to subtract this away the same value here, which means I'm always going to get 0 as my answer, no matter what number I plug in. If you notice, these two guys are the same. 2x squared 2x squared. But this guy, I'm subtracting away, so that means my range will always be 0. No matter what I plug in, I will get 0. Okay, guys, we'll stop there.